In this problem, we have given data on beginning value of the share, which is P naught, and amount is 34 per share, and ending value, which is written as PN, and amount is 39, and finally dividend received during the period per share, which is 1.5. Considering this data, we have to compute two requirements. Requirement number 1, where we have to see that how to compute SPR, and it means holding period return, and second requirement SPY, which is rate of return, and it is called as holding period yield. So considering data, we have to compute two requirements. First requirement, you can see the formula we have written already, which is Pn plus Dn divided by P naught. And second requirement, it is just simplest form of return, which is SPY, where we have to subtract on from the SPR and multiply with 100, because we have to show it is as percentage. So if we just now input into the equation, first equation from the data given, we will get SPR in this way. So there we have the ending value, which is 39. So 39 plus dividend received during the period, which is 1.5. So we have to write 1.5, and beginning value, you can see here it is 34. So if we sum there, we will get 40.5 and 34 here, and it should be 1.1910. So 1.191 is the SPR, or holding period return. So to show in percentage, in the second equation SPY, which is rate of return of the investment, so we can write here as SPR, we have 1.191 minus 1, and for percentage 100 we have to multiply there. It means 0.191 into 100, basically 19.1%. So 19.1% is the holding period yield, which is shown by SPY. So in this way you can compute SPR and SPY in the problem number 1. There you can see from the chapter 1, problem number 1, we have computed this math. So hopefully you have come to understand how to solve this problem. Today we'll see a quick solution on problem number 2. So here in the problem number 2, we have given data on beginning value of the investment, which is written as P naught, and the amount is 65, and the ending value of the investment, as you can see, is written PN, which is $61, and during the period of the holding of the shares, dividend received, which is written as DN, and it is $3. Considering this data, we have to compute two requirements, like in the problem number 1 we have seen, which is holding period return, symbolically written as SPR, and the formula we can shortly write PN plus DN divided by P naught. So this is the first requirement, the formula we have to use to compute that, holding period return. And second requirement, holding period yield. So you can see here that SPY, which stands for holding period yield, and the formula is SPR minus 1, and it should be multiplied with 100 to show in percentage. So just we have to input data from here given into the equation, and we will get holding period return and holding period yield respectively. So I just require to input into the equation of the given data. So beginning value of the investment and ending value of the investment. So firstly we have to write ending value. It is 61, and dividend received during the period, which is $3 of a share, and beginning value 65. Therefore it should be 64 by 65, and we can write here 0.9846. So 0.9846 should be the holding period return. So it is the holding period return 0.9846. Considering this holding period return, we'll be able to find out the holding period yield using this formula, SPR minus 1. So we have SPR here 0.9846. We can write here that we have holding period return 0.9846. So 0.9846 minus 1, and then if we subtract, it should be minus 0.0154 into 100. It means minus 1.54%. So minus 1.54% means that it has the negative return. I mean, considering data on the beginning value and ending value, and also the amount of dividend received during the period, if we consider, then we will have negative return considering data given, beginning value of the investment, ending value of the investment, and dividend received during the period. So in this way we can compute very easily this kind of problem. In the problem number 3, we have to compute different requirements. As you can see here, we have to compute, as per the instruction of the problem, total SPY and SPY when price change only, and SPY dividend only. So these 3 requirements we have to compute. Before going to compute the requirements, we have to compute total SPR to get total SPY, and then SPR price change only to get SPY price change only, and finally we will be able to compute SPY dividend only. To compute these requirements, we have to consider data given. There you can see that initial investment, which is $4,000 given, and number of shares 80. So to get the beginning value per share P0, which is initially we will consider this formula to find out, and the formula, the elements, you can see that initial investment and number of shares. And also we have given in this problem, I mean problem number 3, dividend received per share during the period, which is $5, and ending value per share, which is PN, and it is 59. And we know that SPR meaning the holding period return, and SPY holding period yield. Considering the data computation, we will be able to solve the requirements. So here we have to just find out the beginning value per share P0, and the initial investment we can see as component. We have to write 4,000, which is given in the problem. So number of shares 80, and if we divide, it should be $50 per share. So now all data we have to compute the requirements. So first requirement, total SPY. To get total SPY, we have to compute total SPR. So here we have PN, which is ending value per share, which is $59. So we have to write here 59, and dividend received during the period per share $5, and beginning value per share which is 50, we have computed earlier, and just computing this we will get SPR. So here it is 64 by 50, and we can write here 1.28. So very simply we will get SPR 1.28. Now we will have the first requirement, total SPY. Here the formula you can see, total SPR minus 1 into 100. So we have total SPR 1.28 minus 1, and we can write like this, 0.28 into 100. It means 28%. So 28% should be the total SPY, or total holding period yield. Considering this requirement, we will move forward to compute next requirement, which is SPR when price change only. So there we will consider only the price, which is actually $59. The first initial price per share, actually the $50, and it gets changed to the amount of $59. So we have to write here PN only, as we have been told that we have to consider price change only. So amount is 59 by the beginning price, which is $50. We compute it there. So if we compute, then it should be 1.18. So 1.18 is the SPR when we just consider price change. So now SPY when price change only, we can write SPR PCO. PCO means price change only. Just we have written here as per the instruction, 1.18 minus 1. So here we can write that 0.18 into 100, it means 18%. So only price consideration we can compute that the SPY 18%, and before we have seen that total SPY, which is 28%. Now we'll be able to compute last requirement, SPY when dividend only. So this formula we can consider SPY dividend only equal total SPY minus SPY PCO. I mean SPY holding period yield when price change only we consider. If we use this formula, we will be able to get the SPY dividend only. So we just input here total SPY, we have 28% minus SPY price change only, we have 18%. So if we subtract, we will get just 10%. So only considering the dividend, we will have the holding period yield, which is 10%. So in this way, you can be able to compute this problem or related problem. So hope you can understand the solution of the problem. Well, in the problem number 4, we have to find out real rate of return. To compute real rate of return, we have to have nominal rate of return. So in the problem number 4, we have to consider the nominal rate of return, which we computed in the problem number 1, 2 and 3, the holding period yield or SPY. So as you can see that in the problem number 1, SPY, we have 19.1%, which is 0.191. Then in the problem number 2, we have SPY, which is 1.5%, or we can write numerically minus 0.015. And thirdly, in the problem number 3, SPY, where we see that 28%, or numerically we can write 0.28. And also we have given in this problem the inflation rate. So two different inflation rate we have here. So first one is 4%, so it can be written as 0.04, and also inflation rate 8%, 0.08. So as I have already told you that we have to find out real rate of return. Here you can see the real rate of return. We have to use this equation or formula, where in the numerator part 1 plus nominal rate of return. So here nominal rate of return, I said that we have to write SPY, and in the denominator part 1 plus inflation rate. So we have two different inflation rates. We will see what should be the real rate of return when 4% and 8%, and also we have to subtract 1 from this 1 plus nominal rate and 1 plus inflation rate. So from this part we have to subtract 1 to get the real rate of return. So if we just consider 4% as inflation rate, then in the problem number 1, real rate of return, we can write just input from the data we have. So in the problem number 1, we have nominal rate of return, which is SPY here. So 1 plus 0.191, and we have to divide it by 1 plus 0.04 here. 0.04 is the inflation rate. And subtracting 1, we have here 1.191 in the denominator after summation, and we have also summation of 1.04 minus 1. And after division, we can write here 1.145 minus 1. So after subtracting 1 here, you can write 0.145 into 100 to show in percentage. So finally, we can write 14.5%. So this 14.5% is the real rate of return. And if we just consider the 4% of inflation rate, we have a nominal rate of return 19.1%. So that 19.1%, if we adjust by 4% inflation rate, then we will have 14.5% as real rate of return. So in this way we have to compute both of them, following problem number 2 and 3. So here in the problem number 2, you can see that real rate of return, we have 1 plus SPY or nominal rate of return, which we have minus 1.5%, or numerically we have written here minus 0.015, and same again, inflation rate, here you can see 1 plus 0.04 minus 1. So after summation of numerator, you can see that we have 0.985 and divided by 1.04, so minus 1 here, and then we can write in the next step 0.947 minus 1, and then after subtraction we can write here minus 0.053 into 100, and finally it should be minus 5.3%. It is also negative real rate of return, considering the nominal rate minus 1.5% and adjusting with the inflation rate, we will have the real rate of return minus 5.3% as the real rate of return, as we are just computing real rate of return in this problem, I mean in the problem number 4. And lastly, problem number 3, you can see that real rate of return, we have to just replace the percentage of nominal rate of return, where we have 28%, so we can write 0.28, and we have to divide as the denominator here 1 plus 0.04, inflation rate minus 1. So in the numerator, if we sum, then we can write 1.28, very simple issue. So we have to divide it by 1.04 and subtracting 1 here. And then after division, we can write 1.231 minus 1. And here we will get, after subtraction, 0.231 and into 100. And finally 23.1%. So 23.1% should be the real rate of return. So considering 28% as the nominal rate of return, if we consider 4% of inflation rate, we will have finally 23.1% as real rate of return. So in this way we can find out the real rate of return. Now we will see the next part, where 8% of inflation rate, at that time what should be the real rate of return on the basis of given nominal rate of return, or SPY here in this problem, 19.1% minus 1.5% and 28%. Well, in the time of inflation rate 8%, we have to just change the rate of inflation in the denominator, where you can see that 1 plus 0.08, which is the 8% of inflation rate. So same again, we have to consider SPY, or nominal rate of return, 19.1% in the problem number 1. So 1 plus 0.191, and we have to divide it by 1 plus 0.08 minus 1. So here you can see the value 1.191 in the numerator, and denominator 1.08 minus 1. So if we divide, we will have 1.1028 minus 1, and then after subtraction we will have 0.1028 into 100. So finally we will have 10.28% as real rate of return, considering the 19.1% as nominal rate of return, here SPY, and 8% of inflation rate. And in this way, in the problem number 2, when nominal rate of return is minus 1.5%, that time we have to write 1 plus minus 0.015 by 1 plus inflation rate 8% and minus 1, and after summation we will have in the numerator 0.985, and in the denominator 1.08 minus 1, we will have 0.912 minus 1. So after subtraction we will have minus 0.088 into 100, and here we will see minus 8.8%. So minus 8.8% should be the real rate of return, considering 8% of inflation rate. And finally, in the problem number 3, when the nominal rate of return, or SPY, 28%, that time we just require to input into the equation 1 plus 0.28 in the numerator. In the denominator we have to just input 1 plus inflation rate, which is 0.08 minus 1, and then we can write a sum in the numerator 1.28 by 1.08, then subtracting 1, and after division we can write 1.1852 minus 1, and after subtraction it should be 0.1852 into 100, and it is 18.52% as real rate of return, considering 28% of nominal rate and 8% of inflation rate. So in this way you can compute real rate of return from the given nominal rate of return, considering any percentage of inflation rate. In the problem number 5, we have to compute a number of requirements. First requirement, we have to compute their arithmetic mean, and the very next requirement we will see how to measure the standard deviation, and then we will be computing the problem or the requirement, which is the coefficient of variation, and last requirement we have to compute the geometric mean of two stocks, stock T and stock B. And also we have to make some of the decisions how we can choose preferable stock or desired stock between stock T and B. So initially we have to write the problem number 1, where we have to compute arithmetic mean. Arithmetic mean is also called shortly as AM. And first stock, as I said, that stock T, there the arithmetic mean we can write R bar, and stock T, R bar means the arithmetic mean, or it is the symbolic form of arithmetic mean, we can say. So R bar T, the formula, as you can see there, sum of R T divided by N, so return of each of the year for stock T, and that should be sum, and then divisor we have to consider here N, I mean number of stocks return, or we can say number of years or number of variables, whatever. So here we have given different years, I mean total 5 years data on the return of the stock T. There you can see 0.19 is the first year return, and then 0.08 is the second year return, and in the third year minus 0.12 it is the negative return, we can see in the problem, and then fourth year it is minus 0.03, and last year in the fifth year it is 0.15. So we have to first of all input data from the problem, and that should be divided by 5, as I said, that number of years or number of variables or number of returns. So if we sum, then it should be 0.27, and we have to divide it by 5, and after division we will have 0.054, that should be multiplied with 100 to show in percentage as the rate of return, so we will get 5.4%. So this is the way that we can follow to compute arithmetic mean for stock T. Now come to the computation, similar way for stock B. Same again, R bar B, I mean arithmetic mean for stock B. There we can write sum of RB and divided by number of years or number of returns. So B number of returns, as I said, in there you can see that B 1, 2, 3, I mean number of returns, as many as return we will have, we have to just sum there in the numerator. So for first year we can see for stock B it is 0.08, then second year it is 0.03, and next year we will see there minus 0.09, and then next year fourth year it is 0.02, and for fifth year it is 0.04. All the returns we have to input in the numerator, and there we can see that denominator it is n equal 5, total 5 years, or number of returns we can see there 5, so we have to write as 5. So if we sum the numerator, we will have 0.08, and that should be divided by 5. So here after division we will get 0.016, and to show in percentage, as I said, it should be 1.6%. So this is what actually we have to compute arithmetic mean using the formula you can see there. So this is what actually you have to follow while computing arithmetic mean. So if we want to make decision in the problem number A, I mean requirement number A in the problem number 5, then we can say that stock T is desirable. Why stock T is desirable? Because if we consider the output or result of stock T, it is 5.4%, and for stock B it is 1.6%. So it is higher than stock B. I mean the return of arithmetic mean return or annual arithmetic mean return is higher than stock B. So stock T is acceptable or desirable stock for investor because it provides higher return than stock B. So we can say that stock T is desirable than stock B because arithmetic mean return annually of stock T 5.4% is higher than arithmetic mean annually of stock B is 1.6. So this is how you can write a few words to conclude this requirement, first requirement. Now we will see computation of standard deviation in the requirement B. As you can see there, we have written already that standard deviation, which is shortly written as SD. So for stock T, and as we know that standard deviation is symbolically written as sigma. So there you can see that sigma T, I mean standard deviation measures the risk, so risk of stock T or sigma T. So the formula we have to follow here to measure the standard deviation or the risk, there root over and then sum of RT, I mean individual years return, minus R bar T, I mean mean return of the particular stock here T, and it should be whole square, and we have to divide it by n minus 1. Here we have subtract 1 because we have considered this data are sample data. So if we find that sample data, then we have to just subtract 1 from number of observations or number of years. So we can see n-1, this is the particular formula we have to follow in this problem or in this requirement to compute. So now we have to just input from the data given in the problem. So we have to whole root all of data. So here you can see 0.19 is the first year's return, and here also you can see, so first year return is 0.19, and we have to subtract the mean return. So we have for t the mean return is 0.054. so we have to every time for 5 years we have to write same average return or mean return, so 0.054 whole square plus 0.08 minus 0.054 whole square plus next year return, I mean third year return, minus 0.12 minus 0.054 whole square plus minus 0.03 minus 0.054 whole square. In this way, last year 0.15, I mean fifth year return, individual years return, 0.15 minus 0.054 whole square. So in this way we have to input data, and we have to divide by 5 minus 1, the value of n is 5, and we have to subtract 1, as I said, that sample data we assuming. So in this way you have to just input. Now we have to sum and square every year's data. Then if we sum, then we will get 0.0657 and divide by 4, because 5 minus 1 it makes 4, so we have to divide it by 4, and after division we will have 0.0164, and after root over the value should be 0.1281, and to show in percentage we have to multiply once again 100 by 100. So lastly we will get 12.81%. so 12.81% is the standard deviation, or we can say risk of the stock T. In this similar way we have to compute standard deviation for stock B. There you can see the same formula, just we have to write here symbolically B for stock B. So sigma B root over sum of RB minus R bar B whole square divided by n minus 1. Similar again. So now we have to just input data of stock B. So first year stock return is 0.08, so we have to write 08 minus the average return or mean return of stock B is 0.016, I mean 1.6%. So we have to write 0.016 whole square plus next year it is 0.03 minus 0.016 whole square plus next year third year it is actually 0.09, I mean minus 0.09 minus 0.016 whole square, and in this way I mean fourth year and fifth year's data we have to input, and then we have to divide it by 5 minus 1, and just we have to use our calculator to compute the numerator value. So if we compute, then we will get 0.0161 divided by 4, and after division it should be 0.004, and after root over we will get the amount 0.0632, and to show in percentage once again it should be multiplied with 100, and then we will get 6.32%. so 6.32% is the standard deviation or risk of the stock B. So this is the way that you can follow to compute the standard deviation or measure the risk. So if we want to just make decision after computation, then we can see that stock T, it has 12.81% as the risk or the standard deviation or the sigma value, and for stock B it is 6.32%. Higher standard deviation is not acceptable or not preferable or desirable. We will consider the lower percentage of standard deviation, because as the higher percentage of standard deviation shows the higher volatility or higher risk. So we will select that stock which has a lower percentage of standard deviation. So between two stocks here, stock T and stock B, we can see that stock B has lower percentage of standard deviation than the stock T, which is 12.81%. So here we can write few words that stock B is preferable than the stock T on account of a standard deviation of stock B, which is 6.32%, than the standard deviation of stock t, which is 12.81%. So in this way you can make a decision or comment after computation of the requirement. So now we will see how to compute the coefficient of variation in the next part. Now in the requirement C, there you can see that coefficient of variation, it is written shortly as CV. So we have two stocks, stock T and stock B. So for stock T, it is CVT, and the formula, as you can see, it is the relativity of the standard deviation and return, or arithmetic mean. So mean return. So there you can see that sigma T by R bar T. So there you can see we have just input the value we have computed in the requirement B, their standard deviation for stock T, it is 0.1281. So 0.1281, and that should be divided by arithmetic mean or mean return. So mean return here for stock T is 0.054. So here 0.054, and after division it should be 2.37. And for stock B, as you can see, it should be CV for stock B, and we have to write there in the numerator part the sigma B, I mean standard deviation for stock B, and that should be divided by R bar B, I mean the mean return or average return for stock B. So we have a standard deviation in the computation for stock B, we have already computed. So it is 0.0632. So you have to just input there 0.0632, and that should be divided by the arithmetic mean of this problem, which is for stock B, and it is 0.016. So 0.016 we have to input here. So after division we will get 3.95. So here this measure actually shows that the stock T is preferable because it has lower amount of coefficient of variation. So we can conclude that stock T is preferable than stock B by this measure due to the lower CV, which represents the lower risks. And as you know that for the investor, if it is lower risk, then they go for making investment decision. And for this measure we will just prefer stock T than stock B, because stock B has higher CV, which shows that higher volatility or higher risk. So between two stocks we will go for stock T. So in this way you can also compute or measure the requirement of coefficient of variation. Now we will move forward to compute last requirement, requirement D. There we will see how to compute the geometric mean. Well, in the last requirement, there you can see that geometric mean, which is written as GM. Therefore, for stock T, GM for stock T, and the formula precisely you can see there that pi 1 divided by n, it is the power minus 1, and pi, where we have written as the product of returns. And details formula, if you want to know, then we have to write like this formula, I mean extended formula, where 1 plus return 1, 1 plus return 2, 1 plus return 3, in this way for nth time returns we have to just multiply each other. 1 by n minus 1, n represents the number of returns or number of variables or number of years. So this is basic formula that we have to follow while we are just making the measurement of geometric mean. So for stock T, we have first year return 0.19 in the problem you have seen, and second year it is 1 plus 0.08. Then we have negative return, so plus minus, we know that it should be minus, so 1 minus 0.12. And next year also we have negative return, which is 0.03, so we have to write 1 minus 0.03, and last year it is 1 plus 0.15, so we have to write there as power 1 divided by 5. Total number of returns we have 5, so we have to write there 5, and we have to subtract also 1. So now if we just compute and multiply each of the element, then we will have 1.2588 using our calculator. and 1 divided by 5 as power minus 1. So we will get 1.0471 minus 1, and subtracting 1 we will have 0.0471, and we can write it is as percentage 4.71%. So very simply we can find out geometric mean, as you have come to see already. So for stock B, very similar thing we have to compute for stock B, the geometric mean. Here first year return we have to input 1 plus 0.08, then next year 0.03, so 1 plus 0.03, and third year we have negative return, so we have to subtract from 1, so 1 minus 0.09, and next year it is 1 plus 0.02, so it is 0.02 is the fourth year return we have, and last year it is 0.04, so 1 plus 0.04, and we have total number of returns or number of years 5, so we have to write here 5, then we have to subtract 1. Now using our calculator, same again, we have to just compute each of the element and multiply each of them together, and we will just write here 1.1306, and power, there you can see 1 by 5 minus 1. So if we compute this, then we can write 1.0249 using our calculator, and subtracting 1, the value should be 0.0249, or we can write 2.49%. So 2.49% is the geometric return for stock B. So comparison between two stocks, stock T and stock B, we can consider that stock B provides higher return than stock B. It is 4.71%, and stock B provides 2.49%. So stock T is more preferable than stock B due to higher return. So in this way you can compute geometric mean. And now we will also discuss some of the things that in the problem we have been asked to discuss or to make a decision. So let's see how we can discuss those things. Here in this table we can see the difference between arithmetic mean AM and geometric mean GM. Therefore stock T and B, where arithmetic mean is for T 5.4% and for B it is 1.6%. On the other side, geometric mean GM, for stock T it is 4.71% we computed, and for B it is 2.49%. So difference between AM and GM, you can see there for T it is 0.69%, and for B it is negative, you can see minus 0.89%, and the standard deviation for the stock respectively, for T it is 12.81%, and for B it is 6.32%. In short, we can say that for stock T it is AM is greater than GM. In details, the arithmetic mean 5.4% is higher than the geometric mean 4.71%, which is consistent with the general principle due to the volatility where standard deviation is equal 12.81%. Secondly, if we want to discuss about the differences in mean returns relative to a standard deviation, then we have to say the difference between the two stocks lies primarily in their risk-return profile, where stock T has a much higher mean return, both arithmetic and geometric, than stock B, but it is also has a much higher standard deviation, 12.81% versus 6.32%. This means it is the higher return, higher risk investment. While stock B has a lower mean return but significantly lower volatility, it is a lower return, lower risk investment. Finally, a risk-averse investor would prefer stock B because of its lower volatility and generally a smaller difference between arithmetic mean and geometric mean. In contrast, a risk-tolerant investor would likely prefer stock T because its higher returns, when adjusted of risk using the coefficient of variation CV of 2.37 versus 3.95, which indicate it offers better compensation for the risk taken. So finally, we have come to an end of today's class, or this problem number 5. Hopefully you have come to learn how to compute these requirements. So for today, it's very goodbye. Hopefully we'll be meeting in next some classes. Dear students, today we are going to learn how to compute or how to measure the expected rate of return in the problem number 6. So there, as you can see on the board, that we have written expected rate of return, which is symbolically written as ERI. I mean expected rate of any stock. Here name of a stock is Madison Beer Corporation. So we have just written general formula. So expected return of stock I, and where you can see that the symbol of summation. So summation of the return of individual stock or any stock, or here I have written that I, and the probability of related stocks, so PI, so RI into PI. This is the general formula or the precise formula, where you can see that RI meaning that rate of returns of stock I, and PI is the related probabilities of stock I. So this is the concise formula or a very short formula, but we can extend this formula by this R1 into P1, I mean return number 1 into probability 1, then plus return number 2 and probability 2 we have to multiply, and in this way return 3 probability 3, then return 4 probability 4. In this way we can go to the nth time last return and the last probability, I mean nth period of time we can consider if we are given as many as returns and related probabilities. We have to just multiply and sum each other, I mean sum together all of them to get the expected rate of return. So in this problem, Madison Beer Corporation, we have the expected return. To compute, we have to just input data from the problem. So here the first return is negative minus 0.1, that should be multiplied with the first probability is 0.3. You have seen in the problem, and here you can see the second return is nil or 0, and there is probability, particular probability, which is 0.1, and always remember that probability should be altogether 1 or 100%. So next return is 0.1, and probability there we have seen that 0.3, and lastly the return is 0.25 and the probability is 0.3. Now we have to just multiply each of the portions. So here first one, if we multiply we will get minus 0.03, then 0 plus 0.03 and then 0.075, and after summation it should be 0.075, or we can write 7.5% in terms of the percentage format, because we have to show in rate of return, expected rate of return, so it should be 7.5%. So Madison Beer provides the 7.5% expected rate of return. So we can show this solution using a particular table which is called as tabular format. So we have already computed in an equation, but we can also represent this problem solution onto a particular table. There you can see we have already drawn a 3-column table, and there you can see the first column rate of return, which is RI, and probability, related probability, which is PI. Therefore we have to just multiply each of the return and probability there, RI into PI. So here we have just input from the data given in the problem. So first return and first probability, then second return, second probability, third return, third probability, and lastly fourth return and fourth probability. So each of the return and probability we have to multiply here in the last column, and we will just sum lastly, and we'll get sum of RI into PI, which is 0.075. That we have done in the equation as well, and similar thing we have just shown in the table, and it is why it is called as tabular format. So lastly we can show the main formula. There you can see that ERMB. So R is the expected return meaning that expected return, and MB is the medicine beer corporation. This is the name of a stock. We have written their I as the name of a stock. So here medicine beer, so ERMB and sum of RI into PI. Here the return of medicine beer and probability of related return of the medicine beer, and our sum of the RI into PI we have computed before 0.075, and it is 7.5%. So in this way, very shortly and very easily, you'll be able to solve or to compute this kind of problem in near future. So hope you have understood. Computational process of problem number 7 is exactly as the same as problem number 6, which already we have computed. Here in this problem we have to once again compute the requirement of expected return that we have seen in the problem number 6. So here expected return, which is symbolically written as ERI, expected return of any stock, and the formula is sum of RI into PI, are representing that the possible return of any stock and its related probability, which is symbolically written as PI. So the formula, as we know that the extended formula especially R1 into P1, R2 P2, R3 P3 and R4 P4 in this way to the nth period, Rn Pn, or I mean last return and last probability that we have to multiply, then we can sum to get the expected return. So here for the Laurent computer, so Laurent computer, expected return of Laurent computer, the given return, possible return and its related probability we have. So we can see there that minus 0.6 and probability is 0.05. So it is the return and the probability. So we have to multiply, and next return is minus 0.3, that should be multiplied with the probability, it is 0.2, and then it is negative once again the return, possible return, which is 0.1, and probability is 0.1 as well. So next return is 0.2 and the probability is 0.3, and then we can see that 0.4 and probability is 0.2, and lastly it is 0.8 and the probability is 0.15. So in this way we have to input into the equation. So here you can see that we have computed using our calculator. First one is minus 0.03, then minus 0.06, then minus 0.01 and the plus 0.06, then plus 0.08, and lastly it is 0.12. So if we sum, then we will get 0.16, and multiplying with 100 to show in percentage, it should be 16%. So using this equation we can compute the expected return. So this equation we can present onto a particular table. So here we can also present in the table like this to get the expected return. So here calculation of expected return for Laurent computer. So where possible return we have to show first column, then probability, which is PI, here related probability we have to just present, and then RI into PI. So we have to multiply possible return and probability like in the equation what we have done. So each of them we have to multiply, then we have to sum all together to get summation of RI, I mean possible return, and the probability. So it would be the same as we computed in the equation. So the expected return for Laurent computer, it should be 16%. So it is very easy mathematical computation. Hopefully you have come to understand how to solve this problem as well, I mean problem number 7, and it would be very helpful to compute for your next exam or elsewhere.
To present greater risk, I should acquire lower in computer stock. So discussion and reasoning. Expected return. Lower in computer has a significantly higher expected return, which is 16%, and comparing to Madison Beer, it is 7.5%. Now, if we focus on risk volatility, there we can see that low-in computer has a much wider range of possible outcomes, including a potential minus 60% loss and a potential plus 80% gain, and a higher concentration of extreme outcomes, that is 5% chance of occurring 60% negative return and 15% chance of occurring 80% positive return. So Madison Beer's possible returns are much more tightly clustered between minus 10% and plus 25%. Finally, we can conclude that the greater dispersion of possible returns for low-in computer indicates a higher level of risk, where higher standard deviation or variance than Madison Beer.
Well, in the problem number 9, we have to compute two requirements. First requirement, we have to calculate the rate of inflation, and very next requirement, there we will see how to measure the real rate of return considering data given. So in this problem, you can see we have given different nominal rates, which is written as R nominal, and we have different investments. First one is T-bills, which is the meaning of treasury bills. As we know that T-bills or treasury bills is issued by the government, and this instrument provides the risk rate of return. Here we have nominal rate of T-bill, which is 5.5%, that can be written numerically 0.055, and very next investment is long-term bonds, which has 7.5% nominal rate, that is 0.075, and lastly common stock, which has 11.6% as nominal rate or 0.016. Additionally, we have given here consumer price index at the beginning of the period, which can be written as CPIN, and the value is 160. And lastly, we can see that consumer price index at the end of the period, which is CPIN plus 1, the value is 172. Considering this data, we have to compute those two requirements. So first requirement, we can see that rate of inflation, which can be similarly written as phi, and the formula is CPIN plus 1 minus CPIN divided by CPIN, meaning that the consumer price index at the end of the period, subtracting the consumer price index at the beginning of the period by consumer price index at the beginning of the period. This is the actual formula of the rate of inflation. So we can just now input data into the equation. So we have the CPIN plus 172, there you can see, and CPIN we have 160, so we have to input here, and we have to consider the divisor as 160, where CPIN, and if we subtract numerator, we will have 12 by 160, it means 0.075 or 7.5% as the rate of inflation. So this rate of inflation we have to consider to measure the next requirement, real rate of return. We will see now how to compute or how to measure the real rate of return, where real rate of return, shortly written as R real, and the formula is 1 plus R nominal, I mean nominal rates, by 1 plus inflation rate. So inflation rate already we have computed, and also we have to subtract 1 for the computation, or it is a part of the formula. Now we can compute or calculate this requirement in a particular table. There you can see that calculation of real rate of return. So first column presents the investment, so T-bills, long-term bonds and common stock. The respective nominal rates we have just input into the second column, 0.055, 0.075 and finally 0.116. Now in the calculation column we have to show the formula here and input the data given. So for T-bills, 1 plus 0.055, I mean nominal rate, by 1 plus 0.075, it meaning the rate of inflation minus 1. So if we compute, then we will get the real rate for the T-bills minus 1.86%. So secondly, long-term bonds, we have that nominal rate 0.075. Here we have to write 1 plus 0.075, and in the denominator 1 plus 0.075, it is the rate of inflation, and minus 1. If we do this or compute using our calculator, we will have 0% of real rate. There is no percentage of any rate for long-term bonds. And finally, for common stock, the nominal rate we have 0.116, and now we just input here into the equation 1 plus 0.116 by 1 plus the inflation rate 0.075 minus 1, and we will have 3.8%. So this percentage are the real rate of the respective investment. So in this way you can compute the real rate of return as well as you can compute the rate of inflation. So hopefully you have come to understand how to solve this problem, and I believe that if you given this kind of problem in the near future in your exam, you will be able to solve. To compute problem number 10 is a matter of a minute. There you can see we have given data on growth rate, and which is written as G, and the percentage is 3, where we can write 0.03, and also we have given rate of inflation that can be symbolically written as a small pi, and it is 4%, or we can write 0.04. We have to find out here as requirement nominal rate of risk-free return, or NRFR, where the formula we can see that 1 plus g into 1 plus pi minus 1. So this formula we have to follow to find out nominal risk-free rate of return. So there you can see that we have just input into the equation given data 1 plus g, I mean 0.03, the growth rate, into 1 plus 0.04, which is the inflation, and we have to subtract 1 from the component of the given data. And if we just compute here, we will get 1.0712, and subtracting 1, it should be 0.0712, or we can say it is 7.12% as the nominal rate of risk-free return, or we can say NRFR. And as approximation, we can write NRFR, or the nominal rate of risk-free return, is equal the growth rate plus inflation rate, which is 3 plus 4, I mean 7%. So this should be called as approximation. So in this way this problem can be solved. Hopefully you have come to understand how to compute the nominal rate of risk-free return of the problem number 10. Now we have to compute problem number 11. So here we have given in the problem number 11 risk premium, and it is 5%, so we can write 0.05. And there we have to also consider from problem number 10, which is nominal rate of risk-free return, or NRFR, and we computed there 7.12%. That can be written as 0.0712, and also we have their approximation, which is NRFR equals 7%. So this data we have to require to compute the required rate of return on common stock, and required rate of return we can be able to write their KE, and the formula we have to use here 1 plus the nominal rate of risk-free return, there you can see NRFR, and 1 plus risk premium minus 1. So this equation can be used to find out required rate of return on common stock. So we can write NRFR, which is the nominal rate of risk-free return, 7.12%. So we have to write 0.0712, and we have data on risk premium, which is 5% or 0.05. So 1 plus 0.05, and from there we have to subtract 1. So if we compute, then we will be able to get 1.1248. So if we subtract 1, it should be 0.1248. It means it is 12.48%. So required rate of return for this problem we have 12.48%. Now as per the requirement, we have to consider approximation, which is KE, where NRFR approximate, which we have 7% plus risk premium. So we have 7% plus 5% equal 12%. So that should be approximation of this problem to get the required rate of return. Well, in part B, we have to discuss the impact of the required rate of return on stock prices. Let's see how we can discuss about the impact of required rate of return on stock prices.
Well, in the requirement B, the impact of increased risk first. So if common stock investors become more risk averse and stocks become more risky, this will increase the required risk premium. On the other hand, impact on required rate. The greater risk premium will increase the required rate of return on common stocks. Investors will demand a higher return to compensate them for the increased risk and or their greater aversion to that risk. Finally, impact on stock prices. Since the required rate of return is used to discount future expected dividends or cash flows to arrive at the current stock price, a higher required rate of return will result in a lower present value of those cash flows. Therefore, the stock prices would fall.
You have come to understand this problem number 11, and if you are given this kind of problem, hopefully you will be able to solve in the near future in your exam or anywhere. Finally, we are at the end of the chapter number 1. There you can see that problem number 12 we have given here the required rate of return K equal 14% and rate of inflation pi is equal 5% and growth rate we have given 3%. Considering this data, we have to find out number 1 nominal rate of risk-free return, which is NRFR, and the equation, as we know, 1 plus g into 1 plus pi minus 1. So if we just input from the data given into the equation, then we can be able to find out NRFR. So it is 1 plus 0.03, I mean growth rate, into 1 plus 0.05, which is the inflation rate, and minus 1. So if we compute, then it should be 1.0815 minus 1, and it is 0.0815, or it is in percentage 8.15%. This should be the nominal rate of risk-free return, or NRFR, and for approximation, if we consider, then we can write directly the growth rate plus inflation rate. It means 3 plus 5 equal 8%. And secondly, we have to find out risk premium using this formula, where risk premium is equal KE, I mean required rate of return, minus the NRFR, which is nominal rate of risk-free return. So if we subtract 14 minus 8.15, so we have here 8.15%. So 14% minus 8.15%, we will have 5.85% as risk premium, and its approximation should be risk premium equal KE minus the nominal rate of risk-free return, which is approximate, which we have 8%. So KE is given 14% and approximate NRFR, which is 8%. So 14 minus 8 equal 6%. So 6% should be the risk premium as per approximation. So you have come to understand how to compute this problem. I mean problem number 12, which is last problem, as I have mentioned there. You have come to learn how to compute a nominal rate of risk-free return and the risk premium, and its approximation computation. So hope these chapters and all these problems you have come to learn. So it concludes today's class and this chapter as well. Hopefully we will be meeting in the next class. Till then, stay happy and very blessed.